Hello and welcome back to the Code Maven Programming Bootcamp. My name is Gabor Szabó. Nora, welcome back again.
Hi.
Hi. We are going to go on to the next chapter. In the previous video, we covered quite extensively the exercises of the previous one, and now we're going to get to the next chapter, which is about formatted printing. And this is going to be a relatively short chapter, and then as I see, it doesn't even have exercises. And then we go on for the next chapter, which has a lot of content and a lot of things to learn and practice. So I'm going to even jump over here a couple of slides because I just realized that probably I have some leftover slides there. Anyway, so you want the basic thing is how to print out stuff on the screen.
Your screen is not shared yet.
Yes, thank you. Thank you. So let me go back to the, yes, so, right. So this is the formatting chapter, okay? So I'll just, here I was pointing at and explaining, but this is the formatting chapter. Okay, so formatted printing. The idea is that you need to print out something to the screen. And so far we used print, right? And we use sometimes commas between them, sometimes plus to concatenate them. And even so once that I had used this dot format, and then we also saw the F strings, which start with an F letter and then we embed in curly braces. Now let's try to formalize this thing so it's going to be clear. So here is the first example. Let's say we have two variables, age and name, a floating point number and a string, and I would like to print them out. So there are like 4 ways here to print them out, and I'm going to show them. So the most basic way that you can do is to print out. So you want to print out basically this text. Okay, this is what we'd like to get. So you print out some text and then the value of the content of the name, and you concatenate them with a plus sign. Okay, one step back. We are not printing here yet. We are just creating a new string. So I just wanted to show you that these whole things, all operations that we do, they don't need the print actually. So if you would like to create a text and later print or send it in an email or save it in a file, it doesn't matter. So we are using print because that's the most obvious place to use these things. But in general, these operations can work anywhere. So the first one was the plus sign, where you concatenate the values. And as you can see, I had to put str, call str on the age, because age is a number, and you can't, if you plus together a number and a string, then Python will tell that it can't do it. So I had to convert it into a string. It's quite similar to the conversion using int or float when you're converting to an integer or float. Now in this case, we just convert it into a string, which is basically just thinking about it as having quotes around it. So it's just the same values as you would see when you write it down. But strangely here, I didn't put str because I didn't need it, because that's already a string. Okay, and then this can be confusing. And if I do put an str, so it'd be the same everywhere, then it will be confusing in another way, because then people will come, why is there str? There's no need for str. Am I missing something? So that's also an issue when you put these extra calls that you don't really need, but you put them so it be the same. So that's like the most basic way to create a string that in the end, if I print it out, look like this. The second way is using this percentage signs, so %s. These are the placeholders. And I'm showing this a second because historically, this was the second way, basically, or the first way in Python to create these, to have these placeholders in strings. This comes originally from, I think, from the C programming language, where there was a function called printf, and the function called sprintf. That's why it's also in the title that you have these words. And this is quite standard that there are all kinds of these percentage signs. S is just saying that it's a string to embed it as a string, but there are lots of other ones. And Then in Python, what you would write is that you put these placeholders. Let's say in this case, I have 2 placeholders. And then after the string, I have another percentage sign. And then in parentheses, I have the values that I want to embed in these locations. So the fact that they are in parentheses, these turn them into what we call a tuple in Python, which is not that important right now, just in case you encounter this. And this was around in Python for ages, and it's still around, but it's not the recommended way to write because it's a sort of strange syntax. Okay, it's familiar. It is familiar for people coming from many other programming languages, but in Python there are better ways to do it. The second better way, or the next step, is putting these pairs of usually empty curly braces. Sometimes there are even signs in them. And then after the string saying dot format, and then the values that go into these pairs of parentheses, pairs of curly braces, sorry. Okay, so the first one will go into the first place, the second one in the second place. And this is already better than these tools in all kind of ways, that you don't have to go in them. This person this time was really strange and problematic issues. Both of these can have all kind of extra parameters, making the whole thing very flexible. But in both of these cases, these are already much better than the first one, when you had all these operators, the plus operators breaking up your string, and it's really hard to see what's going on here. It's much easier these days. And probably the best way to do today is to use what we call an F string. F strings are available, I think, only from Python 3.6, maybe 7. I don't remember the exact version number. So we are now 3.8, so we are well there. But and this is an issue, if you have to have your code running on old versions of Python, then you can't use these new constructs, the F string, for example. So you have to think about it. If you would like to make sure that your code runs on old Pythons as well, older Pythons, then you can't use them. And I think this, for example, this was introduced, I think, in Python 2.6. So it's really ancient, but still, like, okay, if you really need for some reason to support some really ancient version, then you might not be able to use the new features. And that's general in all kind of other places in the language. So newer and better features come in, and when you write code, you have to be careful with them. So the F string would work like this. You put an F sign at the beginning of in front of the string, so it's not at the beginning and before the string. And then in the curly braces, you can put in variable names. And Python will just insert the value of that variable name, of the content of that variable in the string. Okay, any questions here? No, okay. So these are just showing the differences, and the most recommended of course, the last one, but it's up to you what you're using. This is just an example that in this case, in this, like when we had the curly braces and the dot format, then we could you could have indexes. So putting so the order of the curly braces and the order of the variables here are not the same, not necessarily the same, because you could put the indexes there. Not that interesting. Right. So this was sort of in between the two. When people realized that maybe you can put variable names here, but these were still not the variables outside. These were variables given to the format function. So that's just, well, so the one reason to show all of these historical things, because you're probably going to encounter something like this. So not necessarily that to recommend to write this way, but to, okay, so you remember, okay, something I've heard, and then you might be able to locate what does that really do. So here I have an example, which, well, this part we haven't learned, but basically we have a list of small lists. Just think about the matrix. Okay, it's basically a matrix of 2 columns, names and numbers. Okay, and I would like to print them out in a nice way. Okay, and here I have some more code that we partially learn, not really. Um, so we go over the elements of this list, and then we access the first element, which is so every iteration, this is one of these, and then we print out the first one. So we take the first part, which is the string in this case, and the index 1, which is the number in our case, and print them out with curly braces. So just a regular formatting thing. And maybe I should actually have an F version of this as well to show you. But with the F strings, we could do the same basically. But now let's focus on what we have. So when I run this, this is the output I get, which is quite messy. I mean, that's the fact that it's messy here. It bothers the programmer. The fact that it's messy here bothers the person looking at the result. I would much better have this like this. Okay, so like the first three rows. So having enough spaces after the text, so they will align as one column, and then having enough spaces before the numbers, so they will align well on the right-hand side. So you are normally, I mean, if you're editing a file in Word and you have all this data, then you're creating a report, then you invest quite some energy into making these tables look nice. So basically that's what we do just now programmatically. So here, this is what we have here. Okay, so what we have here in this case is in the curly braces, I put colon less than 8. So the colon 8 means that I would like to have a field which is 8 characters wide. If you print there something which is less than 8, then just pad it with zeros. And the less than sign here actually means to have it left aligned. So that's why they start from the beginning. The second part, which says colon and then greater than 7. So the colon 7 basically means it's a field of 7 characters wide, and pad the rest with spaces. And the less than, the greater than sign, it points to the right. So it means to make it right aligned, that column. So that's what made the first 3 rows nice. Okay, it didn't help us in this one, and I wanted to show that it doesn't always help because, well, if the string is longer than 8 characters, then nothing can help. If you just be longer, it will be longer. And if the number is too big as well, then again, the Joe part here, the text part is good, but the number now is not really aligned. So this tool is good, especially if you know exactly what is like the maximum bits and the maximum size of the number, then the tables will really look nice because you can put them there. If you still have something longer, then, well, you can even programmatically first go over the values, check the length of each of them, and then create this part programmatically. So you don't have it hard-coded. You could even do that. And then based on your data, you can create the table as wide as you would like. Okay. And you can do this with the F strings as well. I don't think that I have the example here.
Is there a way to look for the longest entry in each column?
It's just you have to go over all the list, all the elements, and so you have to have a new loop, a separate loop before that to go over and then do that.
Right.
Okay? But that's I mean, we'll learn about this soon. I just wanted to show something that I needed a tool to go over all these values without me printing them one by one. Okay, and so there's this pipeline. This is just this pipeline, nothing. It's just a character. And here you can see that what I mentioned once, that you can multiply a string as a repetition, so string repetition, and then it just puts in these dashes, which are just to separate these things. but can be used for the graphical design of text reports. Here are a couple of examples here. So in the strings, in each one of the strings, I put the single quotes just so you can see the two edges of the field, not for other reason. And then inside you can see some way of setting the width of the field and the alignment. So the default is basically the same as the second line. No, actually it's not exactly the same, sorry. But the default is just printing out some stuff, sorry. So it just put in the value as it is, no padding. Then here I have 12 padding, which is the same as the left alignment. So that's what I wanted to say, that's the default. Left alignment is the default. So these are, both are the same. So you can see the padding is on the right. I can put to the right, and then the padding is or padding on the left because we have alignment to the right. And if you put a caret in there, okay, then it's trying to do center alignment. So trying to put, well, almost the equal number of spaces. If it's an odd number, then it's not equal on both sides. Okay. I mean, these are nice things, these string formattings when you're trying creating a text report. And these days we are, well, I guess we still do a lot of these because that's why in Python they invest more in writing this nicer. But more of the reports are PDF files, and then it's a separate module in Python that will allow us to generate the PDF file or HTML, so it's a web page. Or even we can create our own Word file if that's what we really want to do. And they are both, all of them need extra modules to do. But if you are doing text formatting, that's okay. We can also have this special signs here. Again, this is the format. I probably should have some of these F strings. So these are just several signs that allow us to format the content in different ways. So for example, here I have the number 42, and I say display it as a binary. So this is going to be the way to see as a binary number. And I can say it display the character. So you might recall the ASCII table and the Unicode table. So this basically, that's what it does. Or as decimal number, which is what you would probably expect here, is 42. You can, as an octal number, as a hexadecimal, as a hexadecimal with uppercase letters. So it's all these funny things, and just as a number, okay. And I think the curly braces defaults to decimal. You can also have floating point numbers, so that's you need probably more floating point numbers if you're doing whatever you do. Research, then there's all kind of these scientific ways to show a number. So I have this number, it's a floating point number, and then you can show it in various different ways. You can ask it to set the precision to 2, or you can ask it to have exactly 6 digits, no matter where the decimal point is, just to make sure that you show 6 digits. So you can all of these different things, and there's going to be an exam at the end of the course. You have to remember all of them. So just stuff showing off that you can do things. So the F strings, oh, actually, okay. So I have here some of the examples with F strings. So I have various variables, and I can embed them just as they are. I can put here the colon or the right alignment, left alignment. Oh, sorry, the phone is ringing. I hope someone is going to answer it in the home. Sorry for the noise. And strange. I'm sorry for the interruption, both for you and for all the people who are watching the video. I'm really bad at video editing, so I won't cut this out probably. Anyway, so you can see the alignments here, both for strings and numbers. You can see the floating point. This is the number of decimal points. So all of this you can be done. And I'm not sure if I even recommend this, but you can do this. You can even put expressions in the curly braces, and the expression is going to be executed, and then the result included in the string. So in some cases, this might be a good idea. In other cases, maybe it's better to do the calculation before, assign it to some variable, and embed this variable. I'm not sure how to decide here. Probably case by case. What else? So this is just a slide with the old syntax. We can really skip this one. Even more strange examples that I think it's better just to skip them now. If you really would like to see strange examples, then just go over slowly all the examples and see them. Another one just for these are a couple of these examples that I prepared, and then I think it's better not to show them because they are not that useful on a day-to-day basis. Each one of these operators have really fun things to have. This is we talked about the row strings, right? When you start with an R, and now we talked also the F string, so you can actually combine the two. So it's RF or FR. So now this is both okay, so this is just a variable name. And if you put the R into the string, then you will print out the \n, but you will print out curly brace, name curly brace, as in this case, because it's not an F string. Okay, so here in this case, I wanted also both having a \, so it not being a new line. That's why I put the R. But I also would like to embed the variable into the variable, the value. So having just the R doesn't work, having just the F doesn't work because then it's a new line. So I can combine the RF and I can both, you can both have it in both ways. I think they both do the same. And the only reason I think I probably prefer that because the editor I'm using somehow prefers this one, but it's probably just the bug in the editor, so or in the syntax highlighter of the editor. So it probably doesn't matter which order you put them. Any questions with strings and formatting?
No, I think this is pretty clear.
Yeah. It's I mean, to create really nice formatting for stuff, it's an investment of energy and searching for these things, but it's not really a lot of science there. Okay.
Is this something that you would use in a GUI, or is that entirely different?
Okay, so a GUI, so when we're talking about GUI, you're talking about the desktop something, right? So not a web thing. Though in both cases, I think, so in a web thing, so the formatting, yes, because you would like to create some string together, and then it doesn't matter how you print it, how you display it. You just want to, you have some fixed content, the text that you would like, and you would like to embed variables. So that's probably yes. Now in a web way, so it's in a yes and no actually both, because in the end, both web and I think also on GUIs, you would probably use templates. So you have all the fixed text in templates already in separate files, which are not Python in the end. It's just text files, and all the values that come from the program, and then the templating system can combine them. So you won't have free text in your program, and that partially makes it easier for people who edit. Maybe you separate the person who edits the design of the page and the text and the person who writes the program. So maybe at the beginning it's the same person, but at one point it might be separated. It makes it easier to translate because then all the text is in a separate file, and the data, that these are probably just numbers or words that can be translated, like say, I don't know, DNAs or molecules or whatever, that you would use the same string anyway, no matter what language. So those come from the program. Those you don't need to translate, but all the other parts that you might want to translate are in a separate file, and then it's easier to have the translations as well. So yes, I think normally you would have this separated and not using these things. Okay. Right, list. So let's go over the list, and which is the big part of our exercises or lecture now. So what is a list? We already saw a couple of lists, but a list is basically bunch of values separated by commas. Okay, and I'm saying bunch of values because I can't use a list of values because that would be really strange. But it's just a list, as in, would you be a shopping list, or I don't know what lists are there. List of files, list of names, list of whatever. That's what you say probably in English. So in order not to use the same word, I use bunch. So here, this is an example, a rather extreme example of this, because you wouldn't write something like this. But in this example, I have a list. So a list is inside a pair of square brackets, usually, and then they are separated by comma. And as you can see, each element in this one has a different type. And Python doesn't care. So this is integer, a floating point, a Boolean, a non-value, right? This is a string. This is itself a list. So a list can be an element of another list. And this is a dictionary that we haven't learned yet. And a dictionary can be an element of a list. And I don't have a set here, but a set, what we saw actually, a set can be an element of a list. Normally you would have, in a single list, probably all the types would be the same. Because logically, that's the right thing to do. Not because Python enforces it. Okay, so Python doesn't care. Logically, probably you don't say a bunch of things. You probably say a list of names, a list of grades, which are the, I don't know, integers, and the list of whatever which are floating point them. But that's what usually you put them together. So that's what we have here. So square brackets and in integer, usually this. So this is basically the same. And I have a couple of these examples just to help the scientists especially. So whatever, astronomical objects. So maybe you have a representation in Python of some astronomical object, whatever that can be, and then you have a list of them, okay? And maybe from your point of view, they are totally different because one of them is a whatever, a star, another one is a comet, or I don't know, and then for your point of, but on the other hand, they are all astronomical objects. So, but then Python doesn't care. It can chemical formulas, names of files, whatever, okay? It can be even list of functions, okay? So that's why I'm saying to actions to do on your data. And so once we learn functions, we can create a list of functions and then apply the same function on things, or the same thing, many functions. Okay, how do you write it? That's totally flexible in Python. So you can also write it this way, especially if it's long. That might be a good idea to break it up into things. This is usually, now here the indentation actually I think doesn't matter for Python, but it's better to have this nice indentation because that makes it clearer. Okay, this is how I usually format it if I break it up to lines. So the closing is here, aligned. Yeah, so when you print it out, it will look like the same. It doesn't matter. Okay, so list. We here have a list of planets. Okay, variable and the list of planets. If I can just print it out and I get the list of planets, nothing interesting. I can access the len of the planets. So it's the number of elements in the list. Okay, 6. I can access the specific elements of the list by giving it 0 or 3. Okay, so it starts from 0. So element 0 is Mercury. Element 3 is 0, 1, 2, 3. It's Mars. Okay. And I can check what is the type of the actual element. So the element itself is a string. Even though if I check somewhere, if I check the type of the planet, that's the list. But if I check the type of a single element, in this case, it's a string. So I can access individual elements. I can also access sublists, so slices, just like in strings. I can say from to. So here I say from 0 till 1. 0 is included, 1 is not. So this is going to create actually a list which only has one element in it, Mercury. Okay, and I just want to make sure that it's clear that what is the difference between this expression and the one at the top. So here I have an expression when I access a single element, and here I have an expression where I have an access a list, a sublist that has a single element in it. So if you print out, this is just Mercury, this is a list that has Mercury in it. If I ask the type of this one, then it says it's a list. So it's a sublist. I can also access more like other ranges, so 0 to 2, or 1 to 3, or whatever. I can say 2 to the end, or from the beginning till 3. These are all just options quite similar to strings. I could even say this one that says, okay, just the same, all the same. And it's going to be useful probably in, I think I have a slide for that when we try to copy these ones, the list. Just stop me if you have any questions. In general, this is what we can put in the square brackets. So it can actually have 3 parts. So far we saw 2 parts. The first part and the second part are the beginning and the end of the slice. And the third part is the step. So which element to pick. By default, the step is 1. So every element between start and end. And this is basically if I just put 2 columns without any values, that's basically just the same. Pick the defaults. So the default for the first one is 0. The default for the second one is the last element, or the one after actually. And the default for the last one is 1. So it will just give me the exact list that I had. Probably not very useful. Just trying to show how it works. I could put just number 1 here, which would be still exactly the same, because that's the default. So there's no point of writing. I could put the number 2, and then now suddenly it gets interesting, because now from the beginning, 0, till the end, but every second element. So it's A, C, E, F, G, I. Okay, every second element. And I can also say, okay, but start from 1. And then it gives me every second element starting from 1. And I can say from 2 to 8, every second element. So you can have all of this. You can have 1 to 20, every third element, and then it jumps and whatever. Okay? So you can play around with this and then grab some slice of the data. We can change the list. So unlike
sorry, just one quick question. So how come it doesn't give an exception at the last one? Because there is no 20th element, right?
Yeah. So that Python just allows that if you see that because you don't access the actual element, if you try to access the element, that you would get an exception. But because we are sticking the list, it's just okay. We are over it, so don't worry.
Okay.
Okay, so changing the list, as opposed to changing a string that we can't do, here we can actually change the elements of a list. So I have this list brilliantly named X with all these strange series of strings, and then I put in Cuckoo inside. Okay, so I say X in the zeros place has this even stranger string in it. So if I print X out, then I see that it's changed. Okay, that's supposed to list the strings where you can't do this thing. Okay, you can't just go in and change a single character in a string. You can do similarly with a range. So you could say to take the list that's X and the values from 1 till 3 not included, and replace that sublist with these two new values. So the Kukuriku will stay the same because that's the element 0. Element 1 and 2, which are these two in the middle, they will be taken out. So these two will be taken out, and then the new two will enter them. So we'll replace these two by these two. And the last one will also remain. That's what this does. So I select a range and replace it with list, another list. The thing is that the length of this and the length of this doesn't have to be the same. So here I say, okay, select the list of 1 till 3, which are two elements, element 1 and element 2, and replace it with something shorter, which is just one element. And yes, that's what happens. The list got shortened. And I can do the opposite. So I can say 1 to 2, so it's just element 1. Okay, and this will insert the two elements here. Okay, and just to show you something, so now this is okay. Maybe I'll have to fix this slide because it's a little bit confusing the way I have it. So just think about this list again, but now having this operation. Okay, so instead of replacing a sublist, now I'm replacing an element. And the result would look like this. So now instead of having the two elements inside in the middle, now I have a single element, which is a list itself. So it's almost as if it was two-dimensional, okay? So the example is problematic because this operation uses this variable and not the variable, not after this one. Okay, I should probably just create a separate example to show this. Yeah, to make it clearer. But the point here that you can replace, now this could be empty, this could be empty, both could be empty, or either one of them can, and that could be just removing some elements or just inserting some elements. Both could happen. So here, yeah, so that's, I'm not sure how useful this is going to be, at least not in the beginning of your programming career or your work is programming work. I don't think that I've ever used this, but I saw in a couple of examples and that found interesting. So here I have just a list, okay, of values, and then I can use this expression. So this selects every element from one, every second element. And instead of them, I put zeros. And it just injects zeros on every second element. So I can have a couple of ideas when it might be useful, but I have never actually encountered anything in my real production work. But that's actually an interesting thing because the fact that I didn't know about this for many years probably meant that I've never thought about doing this. But maybe I need it. So that's an interesting thing. Yeah. So what happens if I assign a list from one variable to other? So here I have the X with the words, and I make an assignment to Y. So far, so good. And then I change the content of X. Now, I'm not sure if it's surprising to you or not, but both X and Y now have the new Kukuriku.
This was different in a previous example that we did with not list. Was it with the strings?
Yeah,
yes.
Because strings, you can't change the content, you can only replace it.
Right, so yeah, that's when we made the copy, right?
Yeah, so that's why I actually talked about there, because there it was like, it just replaced it.
Yeah, okay.
And this one, it's basically, and now I would need something to draw on, and I don't have here prepared, but basically, think about it that when this happens, Python puts this somewhere in the memory, okay? And the X is just the name of that thing and points to the place in the memory. And when I make this assignment from X to Y, then I create a new name that also points to the same place in memory. So the list exists only once, and X and Y are just two names, basically, to the same thing. Just as probably you also have nicknames, but they still refer to the same person, right? And when you, whatever, get a haircut, it's still the same person. Okay, that's the same thing. So this is the same here, and this can be. So this is probably not very useful when you're just assigning lists. It's going to be useful can be useful when I'm calling a function and passing the list, and then the other function can change this list. Or it can be creepy depending on the point of view. But that's where your real power is. Normally, what we mean here is just to create a copy. Otherwise, I don't really understand a lot. I mean, I don't see a lot of reasons to have a different name for it, other than I want to change one of them and keep a copy. Okay, but this doesn't work by default in Python. So how can I copy this? And that's where I have this operator that I mentioned that it's not really that useful here. So this would be create a copy. Okay, if I put just the colon. And now Y is a copy of Y points to a copy. So now X has a list and Y has a copy of the whole data, whole list. So now when I change X, it changes X, but doesn't change Y. Okay, which is probably what we want.
Yeah, this is, I don't quite understand why this happens. When you make that copy, why wouldn't it change Y as well?
Because think about it. So, well, I can't use the example with you now, but it's basically that in this case here, we have this in a memory somewhere, and X refers to it. And this operator is just how it works. It creates a copy of all the data.
Right.
And then puts in a different place in the memory. Now I can't hear you.
Right, sorry. So here you could actually give like a sublist, right? And then that would be a copy of that sublist.
Right.
And
right.
if you changed the original one, this would still not change. Okay, got it.
Yeah, right. Okay, so yes. Okay, so you have a copy of it. Okay. Now this is good, but what happens if, like in the previous example, we had this here, we had a list, and inside we have also a list. If you do that copy thing, it will create what we call a shallow copy. So it will have a copy of the whole thing, but this internal part will be the same for both of them. Now I really need to draw create some drawing. I'll have to combine this and maybe.
I think that works in Zoom somehow. You can actually.
Yeah, annotation. Can I draw this here? The question.
Yes, I think so.
So here is the list, and X points to this one. Oh, beautiful. Now I just don't know how to clean it later on. Okay, so this is how I have it here, X. And then the first I had Y and pointing to the same place. Okay, so that was the which example? Sorry. How can I now? Mouse, okay. No, I don't know how to switch to the here. Okay. So where were we? Slides here, X, not this one, not this one, this one. Right. So I had X pointing to the memory and then Y pointing to the same memory. So when I changed the location here, it changed for both of them. Okay. So how can I clean this? Do you know? Okay. I think I have this.
No clue.
Oh, I have clear. Yeah. clear all drawings. Okay, so this was the first example. The second example is can I draw here? No, no draw. Okay, here. Sorry, that's
Don't be, it's a learning curve.
It's a learning curve, but I'm not really happy that this is what goes into the recording. But yeah, okay, so I found it. Okay, clear all drawing, sorry. So here is the second example. When this one, I have X pointing here. Okay, my drawing skills are not very good. And then when I have this assignment, then I actually, Python creates a copy of this data structure somewhere in the memory. Okay, and now Y points to this one. Okay, and now it means that when I change it here in X, it doesn't change the Y. Okay, but and that's why we need deep copy. Now I don't know how to switch to the screen. Mouse. Yeah, okay. I slowly understand it. So what happens, and I clear it again. So what happens now if I have this thing? So I have some data structure which has one element and the second element and the third element. And the second element is actually a sublist. So it looks like this. So the sublist is somewhere else in the memory, and this just sort of points there. And this is where X points to this list. Okay, that's what we have. That's when we have a list of lists. Okay, and what happens when we create the copy like we had earlier with the single column? It says Y. It copies this one. Okay, so Y pointing to this new thing, which also has 3 elements. And this is still pointing here. So it was what we call a shallow copy. If we change now coming this element through X, it changes also for Y, because they're deep inside they are connected. And that's why we need this extra tool from copy import deep copy. So we are importing a function from the copy module of Python. And if I use that, the deep copy, then what we have here is, and now I don't know, undo. Okay, I cannot undo here. So I could get to the undo here. And now what happens that the deep copy creates this totally separate structure. Okay, and that means that the 2 structures are now totally separated. Okay. Good. In the end, I managed to draw as well. It is yellow though, but still.
It's still an improvement.
Yeah.
It really helps the understanding.
Yeah, I think so. Yeah, I usually draw it on a board, and I didn't think to try it. So sorry for all the folks who were watching the video and had to go through the trial. And I don't know now how to switch. Okay, I'm back. But how do I? Okay, sorry. When I switch back to trying to use the keyboard, it doesn't work immediately. Okay, so that's what we had the deep copy, and probably I'll create a separate example for the deep copy showing the problem. I didn't have it there. Okay, maybe no, I don't want to waste time on that one. I thought actually writing it. So okay, anyway, join. Join is a function that can take a list of elements and join them together into a string and put some connector between every element, every 2 elements. Okay, so let's say I have a string like this, 1 and then 2 and 3 and then 4 and 5. Just some words, some strings, doesn't matter. Not words, just strings. I can use this. This is the way to use it. So you put the connector, which is a string, and then you say dot join and give the list as a parameter. Okay, in my view, it's a little slightly strange the way it's written, but that's how it's written in Python. But the result is a string like this, connecting the elements with columns. Okay, And let's see, examples list join. Let me take this one now. It's examples list join, because I wanted to show you something here. So what happens if I do the same, but I put a space here? What's going to be the result?
It's just going to be spaces instead of the columns, no?
Right. So that's the same, right? That's okay. The only reason I thought about it is because now it's going to be really, really confusing for the reader, because the looking at doesn't know which spaces was originally there and which one is not. But it doesn't make, I mean, it just points out to some issue that when you create what we call a comma separated values, then think about what is the separator. Okay.
Can you turn a string into list?
Right, yeah, that's going to be the next slide, I think.
Right, because then if you wanted to turn this back into a string,
then you would have problem.
Yeah, then you would have a different one than the original, right?
Right, yeah. I mean, you wouldn't know how to, where to split it up.
Divide, yeah, right.
Yeah. Well, once you start using the word split and not divide, then you will know how to write it in programs, but in Python. Yeah, so divide, yeah. Okay, so let's see what happens if we try to do this with numbers. So here we have a list of strings, and I can use join on them, and it's just created. Okay, that works. But what if one of the elements or more of the elements are numbers? Then the join won't work because we'll get a type error. It says sequence item 1. Okay, that's this one. So this is the sequence. Okay, the list is a sequence. It doesn't say it's a string. It's a list. It's just a sequence for it. Expected to be a string, but it's an int. Okay, so join expects strings. It can't work on numbers. Just as the plus operator, it can't connect two strings sorry, a string to a number. Okay, so what can we do here? And now some really interesting advanced material going to happen here. We are going to use the map function here. So again, this is advanced. Don't worry about it if it's not clear at the first. Map is a super powerful function in Python that gets two parameters. The first one is itself a function. Okay, so the str is a function. And the second one is something that you can iterate over. Okay, so in general, it's what I mentioned, it's an iterable, but let's say it's a list. Okay, but in general, it can be anything that you can iterate over. You can okay, what map does is it goes over all the elements, runs the function, calls the function, passing in the element. Okay, so in this case, it will call str on each one of these elements, and then take the results and combine them together into, well, let's call it now a list. Okay, it's not exactly true, because what it actually returns us is just an iterator that can go over the elements, but it's, let's say it's a bit complex for now, but that's the possibility to go over all the elements that were created by calling str on each one of the elements. So this expression is now actually these things, but all of them are strings now. So now I can use them in join. Okay. In general, map is a super powerful expression because you can put any function there, and then you can, I don't know, you have a list of numbers. Okay, so just double them, or you and get the doubles, or do some computation on each one of them. And it's super powerful because it's also what we call lazy. So it doesn't actually execute the operation until it really needs to. It's an advanced part. Okay, if we reach that part, that's going to be really fun. The same thing basically, or not the same result we can get with this expression. Okay, so this expression says run strx for each x in B. So it basically goes over, x goes over each element of B. So I mean, this expression we already know, right? It's a loop going over element of B. But now we have this execute this function on each code. So it's like a loop, okay? But it's written in the opposite way, okay? And this is called a list comprehension, basically.
Could you write it in the regular way, like having the loop first and then write string?
Right. So you could write the whole thing into a real loop, but
right.
that would need more lines, and the result, and you would need a temporary variable to store the result, and so it would make the code a little bit longer. We can do that one. Well, that's again, then that's also, I mean, this list comprehensions, and these things are more advanced. So these are the part of my advanced course usually, and there we can see all these examples. I'm primarily showing them here to like sort of a teaser, so people will know that they are fun or scary depending on how you think things ahead, and people use this stuff. And right, and then now just remember that we talked a little bit about Perl and Python back when we were offline, and so one of the ways of Python, and one of the sayings of Python, that there must be one obvious way to do things. And now I just showed you two different ways, and some people will say that this is the right way, and some others say that they need to say this is the right way. And now we'll go to the point where, and then there are other people who would just write a for loop and do this. So we have multiple ways of doing things. Anyway, going forward, you asked about how to divide or separate things. So there is a function called split that does this. It's a method of strings. So I can have a string dot split and then colon, and then it will split up the string into small pieces or large pieces wherever it finds a colon, and it will return a list. So words is a list of these elements, of these individual elements that were split up from the original string. And here I have a special case if I use split without saying what to split with, and then it will split according to spaces. So one or more spaces. Normally this would split according to a single colon. So if I had two next to each other, then I would get a space in between them. Let's actually see that. So split. So let's put here, yeah, let's put this one, an extra space, an extra colon here, and then let's run this. Where is this? Here, okay. So this is lists, and Python split. Sorry, wrong place, not linters. Lists, Python split. And as you can see, here I have this extra space. So extra element, sorry, an extra element, no space. Extra element without any content. It's not any content, an empty string. Okay, slowly I can figure it out what I'm saying. So it's an empty string, okay? So because I hid this. On the other hand, when I use split without any parameters, it would just split on any number of spaces. Okay, it's slightly different. It's a special case.
Can you make it split in a way that it only takes every second space or every second colon?
I don't.
Does it have that parameter?
So,
okay.
Not split. No, I don't think that split has any of these extra powers. Okay. And another special case, in case you would like if you have a string and you would like to cut it up into individual strings, individual characters, then actually there is the list function that would convert anything to a list. So it can also take a string and convert it into list basically cutting it up into individual characters. Okay, let me just check for.
So if that string had a space,
Yeah.
And you use the list function on it, then would the space be a different, like a separate character in that list?
What, sorry again?
So in the last example, right? If
Yeah.
you had a space between B and C, would
Yeah.
that be a separate element of the list?
Let's try it. So here you have a space. That's what you meant, right? Somewhere there?
Yeah.
So, yep, there is now an element which is a space itself.
Right.
Which, so just no, this is an empty string, this is a space.
Right.
Okay. Okay, and my suggestion is that now we take a break, because I think maybe I should have taken a break after the formatting part. So we have the chapters, but now it's way too long already that I'm talking and we are having this video. So let's take a break now, and then I continue this chapter about lists. Okay, because I think it became a little bit too long now, and we are both very tired, and also people who are watching this are going to be tired. So thank you very much for watching this so far and being around. See you next video.
See you later.